Okay, I just
Am I
want
looking,
to take it up,
am I,
take it away.
am I looking good? Am I audible?
Yes, we can hear.
Perfect. My name is Ashwath. I'm a recent graduate from Rochester Institute of Technology with a computer science degree. A little bit about myself. I recently interned at a AI startup called Infinitus, working majorly in application security side of things, helping the company to improve the infrastructure and operational sides of the product lifecycle. Have a fair amount of experience with a lot of security related projects at my previous company, from pen testing, network pen testing, couple of IAM projects as well. And yeah, so I'm really passionate about defensive secure coding. Yeah, so this is gonna be a fun workshop for you guys, and I hope this workshop is gonna throw some knowledge at you, starting from first principles, the fundamentals of secure coding, and then slowly probably give you a small exercise to probably check for yourself how you're doing. Can you translate the knowledge that you gain here into the real world scenario? A couple of exercises as well is included at the end. So let's get started. Yeah. So for the content, I'm gonna briefly talk about what secure coding is, why we are doing the shenanigans, what is the context of secure coding, how the secure coding fits into the bigger picture of software development lifecycle, where exactly are we positioning this, what are we supposed to look at, how do we know how do we know if a system is secure or not, and things like that. Then I'm gonna slowly transition into the fundamental principle. The fundamental principles are very similar to the ones that are spoken about in a cryptography class. Probably, again, there's a lot of transferable learning here. You learn a topic from one branch of computer science, and you could probably twist and turn it and then apply it to another branch. So a lot of similar words you're going to be hearing to again here. And then let's and then this fourth point is about coming up with a login system, prototyping a login system using the principles that we have learned so far in the workshop. And finally, a couple of coding exercises, probably some from real world as well. So let's get started. So yeah, I think the first question is why secure coding? What is wrong with the code that is written by developers every day, and what exactly does secure coding here means? You know, um, programming programming defensively is a very crucial part of securing the system by design and by implementation. It essentially means we are writing code that anticipate the malicious actor being present and acknowledging it, and then seeing how can we how can we write program that is not just functional but also can stand strong in the tough times. There are a couple of questions that leads to the leads to secure coding or secure programming as an answer. And first thing is, could someone deliberately try to break the program? As we write software, one of the most important consideration is there a possibility of a malicious actor trying actively to exploit the system? Um, you know, is there a person who is really focused, who is really technically skilled enough to break the system? Yes, of course there is. There are a lot of reasons for that. One of them could be a data theft. Probably you'll be storing a lot of sensitive information in the system. A malicious actor could be trying to steal some information from the application that we're working with. Another case could be a case of a DDoS attack or a DOS attack or denial of service attack, where somebody's trying to just overload the system and causing the system to crash or behave, uh, probably affecting the availability of the system. And again, with a lot of other scenarios as well, like privilege escalation. Could a person try to escalate the privilege given to him and try to do things that he or she's not supposed to? So again, this question directly leads us to the answer of secure coding, or we have to not just write the program functionally well, but it also has to withstand a person who is deliberately trying to break the program, you know. And then there is a very important aspect of this is there a scenario where somebody's trying to accidentally or unintentionally breaking the program, you know. There are a lot of scenarios, right? We press something or try to perform a particular action, but you know the program or the application couldn't handle it well and it crashes or reveals something sensitive, or could be some kind of a weird behavior. So again, this is another important, very important consideration, that we have to write a program that not only protects us from a deliberate hacker, but also protects us from an accidental or an unintentional activity of breaking the system, right? Um, One example I can come up with for the second scenario is when somebody's accidentally trying to break in the system, break into the program, is a buffer overflow attack. Probably a user is just copying a very huge chunk of data, and if the developer has not, sorry, if the developer has not uh, seen that specific test case, then the data, the buffer overflow could be triggered, and it could lead to unintended behavior. Also, there are a lot of race case conditions where a multi-threaded program is running and two threads try to use the same resource at once, and it could lead into a very nasty situations of a dead. Yeah, so it could go. I think one of you did not mute your. Yeah, so some of the examples for unintentionally breaking the program could be a buffer overflow or a race condition. Sometimes even a configuration errors could potentially lead to a breaking the program. So there are multiple reasons why we are securing the program or we are defensively securing the project. And these are the two questions which directly lead us to secure coding, right? Yeah, and let's understand what exactly we mean. Let's understand what is the environment that the program runs. If we understand how the program runs, probably it's easier for us to defend it. Or if we know everything about the program, it's more easier to point to an exact location and build upon it, right? So we're trying to answer a couple of questions here. One such being, what is the operating system in which it is running? uh, what is the network environment it is running on? Is it a program running behind a firewall? Is it deployed within a private network, private cloud network, or is it a public facing environment? What kind of environment is it basically running on? Again, there are a lot of other factors as well, like what are the third party libraries that the program is running using? um, how is the program deployed, and then in the end for the end user, the couple of things about environment which you as a developer should always keep in mind when you're trying to secure it. Because unless you know how exactly the program is running and what exactly it is doing, you have no clue to defend it or secure it, right? Another important question to ask ourselves is, do we really understand the procedure under which the program is being run? What I mean by that is quite straightforward, I'd say. One such procedure could be a startup procedure. How is the program started? Is there an automated process that is triggering the process that is triggering the process a program? Is it running on a container? How exactly are we running the program? That is the startup procedure. The second important question is about runtime procedures, right? What are the actions that's being done on the program? How are we making sure the external uh, does it need any external does it need any database access? Are we securing those as well? Because again, securities the system is only as secure as its weakest link, you know. So again, this again boils down to a fundamental principle to make sure we understand the procedures under which our program is run. Again, I think the final important procedure is the shutdown procedure, where if we want to make sure the program is does the program gracefully shut down, or is the data saved properly with no resource left hanging. So these are a couple of procedures that we should make sure we exactly know how it's working to improve the security of the program. So by conclusion, we're trying to say always thinking ahead of time and in terms of functionality, in terms of robustness, in terms of security, we can anticipate the potential risks, and trying to work on them proactively is basically defensive secure coding. Does that make sense to everyone? Are we in the same page?
And save. But then use a ODF line. And save.
Yeah. Yeah. Sure. Okay, I can give you an example with how secure coding fits into the context of software development. I think we all have faced situations where we try to click on a button, or probably some random action, you know, and we see a screen that is not intended for us. So it's a okay. Let's talk about robustness of the program and security of the program. Robustness of the program is basically how the program handles the unexpected situation. You know, program which is robust might handle unexpected inputs, system failures very graciously without crashing. However, it doesn't mean it's secure. You know, it's only able to handle unexpected situations, but it cannot secure the system. But when we're talking about security here, we're specifically trying to protect the program from a vulnerability or a weakness. Again, there is a lot of overlap between security and robustness of the program, but we're not saying the robust program is secure or the secure program is robust. It's two different things, but robustness of the program can enhance the security, but it's not the other way around. Okay.
Yeah. Oh, you did do it correctly.
Let's set a simple example here of buffer overflow, right? When I say buffer overflow vulnerability might be secure but not robust, I mean the program properly prevents the buffer overflow by using safe coding practices and running with minimal privileges. However, if the program receives an unexpected output,
but you gotta do it though, don't forget. You somehow drop don't drop the class and you don't pass.
All right. There's a lot
Right?
there's a way we can reduce that environmental.
I think the noise, I mean the background sound is coming from the other end, not from my end.
No, what I think someone whose voice. Okay, let me see if I can.
If possible, could you mute the other participants?
Yeah, sorry, I just mute Perea. Sorry.
Yeah. So yeah. So coming to the buffer overflow example, the program probably prevents the buffer flow vulnerability, but given a specific well-crafted payload, it could still cause the program to be stuck in a specific state. So even though the program is not vulnerable to a buffer overflow vulnerability, it could still not be robust. So that's kind of a overview about the system, if it is robust versus secure. So in this context, we are not only trying to avoid unintended behavior, but we are trying to protect the program from exploiting vulnerabilities, right? So the ideal situation is the program should be robust as well as secure. It handles the unexpected inputs and errors very gracefully. It also protects against the vulnerabilities and malicious attacks. It's not very, I would say, it's not very straightforward to build the most robust and secure application. Sometimes there is again a trade-off. So depending upon the trade-off, we design the application. So again, yeah. So how does this all fit together? I mean, this is quite. This all looks like a theoretical overview, but how does it all fit together, right? I can give you a small analogy of how this all fit together. In a restaurant scenario, robustness basically means can the restaurant or the kitchen handle a strange request or a strange request? Can the kitchen handle it? Yeah, I mean the robustness basically means given a strange request, it should gracefully handle it, right? Security basically means we also want to make sure the recipes and the ingredients are safe to use and not cause any kind of contamination or any kind of a theft. So that's the security. What about policies and procedures, right? Policies are basically, always wash your hands before cooking food or handling any food items. Only allow the authorized staff members in the kitchen. Those are the policies. Again, please always look parallel to the application perspective, right? Uh, Here, robustness means, as I said earlier, handling unexpected situations. Yeah, again, going back to the restaurant scenario, procedure basically means if there is a mistake in an order, should always ask the customer for clarification before proceeding. Again, please, it's very straightforward to relate this to the application and in SDLC in general, right? So the context we are trying to put secure coding is we have a unexpected scenario, or we have a individual who is really focused on breaking the system. Is our program good enough to handle those situations? And that's where again secure coding practices comes into picture. And yeah, as I kind of briefly spoke about it, the policies and procedures play a huge role in handling these, secure coding activity in general. Does that clear things a little bit better than the previous slide? Because I felt I was rushing a little bit. So please feel free to stop me at any point of time and raise any questions. I'm just taking it slow for now. It's all gonna fit into place, and we see some hands-on exercises. So yeah, please feel free to raise your hand or shoot up any questions, doubts, whatever.
Can I ask a question?
Sure.
This,
Yeah.
this is a great example how robustness can be enhanced. I'm sorry, how robustness is an enhanced part to be secure. I like that definition a lot. And many times when we talk about security, we're really talking about robustness on the code, especially from the software engineering perspective.
Right.
Now, can you tell us a relationship in your perspective, how an error through exception, through vulnerability, how they are related and how can they become a robustness concern when you deal with secure coding?
That's a great question. So if I understood your question, you're trying to rephrase your question, you're trying to understand what robustness adds to the security, or in a way, if I'm building the most robust product, is it also secure? Am I understanding your question right?
Yeah, that's a great interpretation, because robustness in software engineering, that really means one thing, to make a good code. But at the same time, when you do secure coding, you're doing good code. And you're really doing good code by considering many other factors. I just want to see your point of view on that, and how dealing with errors and exception and vulnerabilities leads to a robust coding?
Sure. Yeah. I mean, I would put it this way. I mean, robustness is crucial for um, again, yeah. So robustness only handles some unexpected behavior, or what if the length of the input is humongously large, what happens in this scenario? Um, what happens if the file upload, if there is a file upload functionality, and if the file is like 1 terabyte or something, what are the system's reaction to it is generally considered as robustness, or how the system reacts to those kind of situations. But if you observe closely, security is trying to, not even just trying to break the system on a behavior standpoint. It's trying to break the system in terms of the design, in terms of the way it is implemented. So the intent to on which you measure the robustness and security are two different things. The intent of measuring robustness is how often can it break, how often can it uh, how often can it behave in a different way than it is intended to. But when you think about security, the intent itself is to protect the system, not just to handle unexpected events. So to put things short, I think robustness helps, but without proper security measure, robustness can ultimately lead to revealing a security vulnerability. So if I see a unexpected situation in the application, I might probe more into it and dig more into it, and that might be a gateway to a security vulnerability. But if yeah, so robustness is like a check, and if that check is broken, it might lead, or it might reveal a lot of other security vulnerabilities underneath. So to put it short, I think it's not enough the program is just robust, but it also has to be uh, secure enough to protect against security vulnerabilities. So again, the doubt might arise: what exactly is a security vulnerability, right? Because um, again, a lot of security vulnerabilities could be, from your question, I think you spoke of quite a bit about error handling. Uh, Error handling, I guess, yeah. So error handling is one way to not reveal a security vulnerability. Could be, if you just look at a login screen, some applications or some websites also reveal that your username is wrong or your password is wrong. You know, so does that mean it is not secure or not robust? I mean, it if if you look at it and look at it through a security perspective, then you should not give user more data than required, or you should not just tell your username is wrong, because if you tell the user the username is wrong, he could just sorry if you just tell the user a password is wrong, then he can just fixate on the username and then try to brute force or use other techniques to break it. So in that perspective, even though even though the application is robust, it's not completely secure. uh, am I even close to answering your question? Does that make sense?
Yeah, I think you give a good context, and that I think it's a good explanation. Um, I just think there is more to the new definitions of security that relates on robustness. It's like a progression that software engineers they have developed for many years, and now it's time to do it securely, which is what we're doing nowadays, right? But at the
Yeah.
same time, kind of covers robustness embedded. So that's what I thought. But please carry on. I was just have another question. Do you have coding examples that you're going to show us?
Yeah, it's coming up next year.
Excellent. Sorry for the interruption. Go ahead.
No, you're good. You're good. I think you helped me to cement a couple of concepts together. So thanks for that. So yeah, robustness is, I would say, a fundamental requirement of a program. It's a developer's job to make sure you're not only passing the minimal test cases. You have to handle all those test cases, and at the same time you should also defend the program's logic. So it's so robustness helps to secure a problem, but alone it cannot do much apart from handling certain situations. So that's how we are trying to put secure coding into context, by distinguishing what robustness means and understanding security is not just about building robust solution, but also defensively trying to anticipate the weakness and trying to tackle it. So I think I can move to the next slide if there's no confusion or there's no more questions on where we are placing secure coding. I think let's discuss a little bit about the design principles. What are the things that we keep in mind before designing a product or designing a particular solution, right? So these are the fundamental principles with which we look into the application. So one of the key objectives for this workshop is you not only have technical, of course, you get to do some hands-on exercises, but think broadly in terms of computer science fundamentals, how you can take the first basic fundamental principles and apply into a real world scenario, right? So these are some of the fundamental principles that acts as a window to the world of software development, secure defensive secure coding. So I think you if you've taken any cryptography lessons or courses at your college, I'm sure you heard most of this. And so just let me just start with the principle of least privilege. Principle of least privilege is very straightforward, I would say. It states that any program could be a process, function, any user, any entity, so it should only have the least privilege possible for it to perform its tasks. It's quite straightforward, but it's very tricky to apply this. Trust me, the principles are straightforward, simple, but it'll all come together when we have a small exercise of designing a login system together. So when I'm talking about this principle, try to connect the dots with where this could be utilized, right? If you think about it, if your application has a process running that doesn't require a root privilege or a administrative privilege, then it happens multiple times. It happens that thousands of hundreds and thousands of users are onboarded to an application, and they're all given a set of privileges. So again, it goes completely against the principle of least privilege, because most of the times you define the scope of a user, right, or a user or entity, right? So unnecessarily giving them more privilege than intended is only a recipe for a disaster. So we are trying to minimize the permission here, of course, and also this kind of has another implication on separation of duties, right? Different components of the system has to be isolated and have very strict boundaries between them, right? That's another implication that we can draw from this principle. And use of the least privileged accounts. We see this a lot, right? In case of privilege escalation, some particular user can escalate his privilege into using a root user's privileges. So many a times when a web server, most of the times a web server is run as a root. So when a technical or when a hacker tries to break the system, he can just try to escalate the privileges. So this principle is basically telling you, whenever you're designing a system, a platform, or product, or whatever, when you're designing a system, make sure all the users have the least privilege possible. Quite straightforward, but you will know the boundaries of it as we talk further into this topic. Example, if an application interacts with the database, you don't have to give it the highest privilege. You don't have to give it a full permissions, right? You can only give read permissions for certain users, and if certain users tries to write something, then from the principle of least privilege, the user doesn't have that privilege. So you can kind of get the bigger picture here. So working with the databases, working with the web server, most of the times, people or the attacker can trick the application by escalating the privileges. So making sure everybody has the least privilege is one of the key principles that one should always keep in mind when developing applications. Okay. Yeah, fail-safe defaults, another key principle for secure programming. It's quite straightforward. I think most of these principles are very self-explanatory, but I'm going to talk a little bit about. I'm going to expand on these topics so that you guys get a bigger picture, right? So yeah, whenever there is a failure in a system, the program should always default or come back to its secure state. Because if there is any kind of unexpected behavior, if the program kind of falls back on a vulnerable state, then it could expose a lot of potential secrets or a lot of sensitive data. So we should always make sure. I think we spoke about error handling quite a bit in the earlier slide. So when you're handling some error, or if you're handling a specific input, make sure you are handling it gracefully and do not reveal any information. I'm not here. Please keep in mind that I'm not specifically talking about a particular feature. It's more of a. It's not specifically. It's not specifically tied to a particular functionality. It's more of a. How do I put it? It's more of a mindset, or more of a. I think it's more of how you handle things, I would say. Yeah. So yeah, let's talk about gracefully handling the errors, right? Most of the times we see, if the errors are not handled well, it could really reveal some sensitive information. So making sure we only send out generic information is crucial here. And we should always, another important key thing here is, if there is any deviation from a regular behavior, you should also make it a point to log those things, because logging and monitoring is crucial for an enterprise. And from the logs, we can probably figure out a pattern of a malicious vector. And also, if we want to reconstruct certain application or an entity, we can again always go back to the logs and figure out how it happened. So not only handling the errors gracefully, should also make sure we are logging it all essential required data. Yeah. Also here we are talking about least exposure. Yeah, I think I covered a little bit about this. We should always make sure we expose the least amount of information. Probably a generic message here could be the most applicable. So yeah, fail safe ultimately means, if you're failing, do it in a way that reaches the secure state and don't give away any unnecessary information to the user. So that's the fail safe default principle. Yeah, again, these are very these concepts are very similar to the ones used in cryptography. So we're just using it in a different context. That's it. And again, so the third principle we're going to talk about is a principle of economy of mechanism. I think we all know if the code is empty, there is no vulnerability, right? So as we writing code, as we keep writing code, we knowingly or unknowingly keep adding vulnerabilities to it. So this principle reminds us how to keep things simple and in a minimalistic way. Again, minimalistic doesn't mean your logic has to be simple, but the way you implement them should not make it overly complicated to the system, because if you make it overly complicated, then debugging might be an issue, uh, finding the vulnerability might be an issue, a lot of other things as well. So economy mechanism tells you keep your system simple and minimalistic, because a simpler system might have a fewer opportunities for an attacker, right? Here, yeah, we're trying to minimize the attack surface here. Um, the less complex the code, the fewer places there are for the vulnerabilities to hide. So straightforward, I would say. And also, we should try to minimize the dependencies, reduce the number of external libraries we are using, reduce the number of external calls that we make from the application. So we're trying to also do not trust third-party libraries we're using very blindly, because the security concern in general is that it is very easy to spread, right? It could be a small component of your application, but when exploited, when chained with multiple vulnerabilities, it could have a wider impact on or wider effect on the whole application. So making sure keeping things simple, neat and simple is crucial, because we are ultimately reducing the attack surface, and we're trying to, yeah, that's the principle of economy of mechanism. Simple example could be if you're trying to build an authentication system, it's probably better to use a well-established system like OAuth than building your own system, because building your own authentication system has a lot of nuances in terms of security. So you might not be well equipped to build the authentication system well, and do not, yeah, so which might introduce flaws and vulnerabilities, right? So keep things simple and neat. Don't overcomplicate the program or the system. Try to minimize the attack surface. Try to minimize the dependencies. So this is the overview of economy of mechanism. Again, these concepts again have a lot of overlaps with the concepts. So please be mindful when I'm talking about this concept. I'm trying to shed some light on this principle, but again has a lot of overlaps on other principles as well. So I might reuse some sentences or examples, but yeah, I'm here to give a bigger picture. Yeah, another important principle is to completely mediate every action, right? What this means is every interaction between a subject and an object should always be mediated. I mean, which might sound crazy in the beginning, because once I authenticate a user, how does it matter? He already has certain privileges, right? But what if that same user that you assume to be safe or not a potential threat could one day decide to be trying something against your system? So yeah, so it's important that every action or every interaction between a subject and an object here, user and the application, has to be mediated. When I mean mediated, it doesn't. When I mean mediated here, I strictly mean checking the permission, or again, it depends on the activity. But in terms of the interaction, I'm saying, does this user has this permission to interact with this resource or not? Does this user have enough permission to access this particular report or not? Or can this user elevate his access to elevate his permissions to access this particular folder or not? So things I'm thinking in those terms. So again, this is not very specific to a particular interaction. This could be multiple other things, but for the sake of simplicity, I'm just putting it in this way. Yeah, yeah. Some of the coding implications here means we are trying to access control at every point, right? You must check that every action, every request or input is authorized before allowing it to proceed, right? As I told earlier, you never know how the program, who the program is interacting with. You never know how what skill sets or yeah, you don't never know. So you can't you can't have any assumptions here. So you don't have any trust assumptions here. So always make sure you're controlling access at every point of your interaction. And yeah, as a security implications, this makes the APIs extremely secure. For example, we don't assume that the user has the right to access a resource just because they accessed it earlier. Could again directly lead to a vulnerability or exploitation of a vulnerability, right? So do not assume things. Always mediate the action, mediate any interaction by checking if the user has enough access to do a particular action or not. Yeah, I think yeah. For example, if an administrator, user logs in and then he decides to delete a particular file, then the program earlier might have just allowed the user because he's an administrator, right? Because instead, if you follow the principle of complete remediation, then even an administrator, before deleting a file, should be checked: could he do it or not? Could he or she do it or not? So having more mediation or complete mediation, in fact, complete mediation gives you more control over the different states, different interactions in your program to make it more secure. Yeah, I think that's a gist about complete mediation. Okay, so I'm going to talk about a little bit about separation of privilege. It's quite, again, self-explanatory. For any action to be performed, any sensitive action to be performed, you need more than one condition to be true. This is a form of redundancy here, but it also increases the security of the product by requiring multiple distinct factors. Some of the examples here could involve having multiple approvals for sensitive actions. For example, you might require both password and multi-factor authentication if you want to access some critical systems or doing some sensitive actions, right? In case of a role-based access control system, you might use RBAC policies to ensure the user tries to access sensitive functions. So in this privilege, in this principle, we're trying to see, can we add more privileges and can we require multiple of those before doing a sensitive action? So you can already see how all these principles are coming, if used properly or if implemented well, improves the security, right? Each principle bring different nuances to it. Here we're focusing on privileges more. In the previous example, we spoke about having more control. So on and so forth. So every principle has its nuances and what they bring to the table. But yeah, when it comes to separation of privilege, there could be an application that allows users to transfer funds, but but in that case, it should not only require a password, but it also should request for a MFA, right? So those are the principles. We're trying to separate the privileges here. Yeah, again, this covers a little bit about robustness of the application, but again, robustness and security kind of not hand in hand, but both of them are important, right? Here we might there might be a question that making it complex, doesn't it take away the principle of psychological accessibility? Yes, I mean, psychological accessibility is a fundamental privilege, that makes user easy to use the application, right? But here we're trying to make it more harder for the user to interact with the application, right? That could be a form of redundancy here, right? But we always trying to see, is there a trade-off between robustness and security? If there is not a lot of trade-off, then we could probably add more security feature and making it hard for a user to access than to make it easier for a user to access and make it less secure. Does that make sense, everyone? Okay. So that's the separation of privilege. Yeah. Principle of open design again. So this is a very fundamental principle. If you look at the examples, we all have used SSL, TLS protocols every day to interact with webs to interact, right? But the protocols might not have the vulnerabilities, but the implementation of those, like OpenSSL, might have the vulnerabilities. So here, the idea is that the security is not because of the it's not because the design is kept secret. It is relying on the fact that the way the way it is implemented, the way in the strength in the design and implementation is higher, right? Because if you want to look at if you want to look at these protocols, it's quite open, and it's an open secret. So the application has to be secure, and it should depend on the strength of its design and implementation than keeping the design secret. Because if you just decide one day you want to obscure most of the code and hope you don't have any vulnerabilities, then it's only a matter of fact that somebody can just obfuscate the program and break into the system. So obfuscation was once a good secure coding practice, but it's no more the case. So more than keeping the design secret, the principle says we should believe in the strength of the design and implementation. Okay, and yeah, the coding implications here, keeping the design public helps you to helps in public peer review, making it more robust, more secure. So this, I think, is a very broad principle, but is one of the tougher principles to wrap our heads around, but is a very key principles in secure coding. Okay.
I have a question. So obfuscation is not considered to be a practice for secure coding, or it is? If you go back to the other slide, you say no because it will violate the principle of open design, correct?
Yeah, I mean, yes and no. Obfuscation is considered to be a poor secure coding practice because if we follow the open design principle, the obfuscation is just trying to alter the way it is represented, and it's just trying to cover the weakness or vulnerability. So it's not exactly doing anything to tackle the issue, but trying just to cover the issue in a sense. So obfuscation is considered as a poor secure coding practice, or is considered to be, in certain cases it works, but you should not just depend on obfuscation as a means of securing the application or a program. So does that answer your question?
Right. But well, yeah, but now I have another question. When will obfuscation be a good practice?
Hmm. Obfuscation, I think it's I don't think it's a good practice, but many a times you might have to uh, package your code or probably distribute your code or something related in those terms. In those cases, if you want to reduce the whole code base to smaller value or smaller size document, or obfuscation might work. I mean, I would say obfuscation doesn't really tackle this problem of secure coding, or uh, doesn't really um, provides any solution for security in terms of doing it better. But I mean, I'll have to get back to you on that because I'm not sure where exactly it could be used. Do you have
Yeah,
some?
no, that's fine. That's fine. I think you did a great job here. I just think obfuscation is still a practice. For example, suppose that intellectual property, for example, is not considered to be too much about security, but privacy and confidentiality, or even intellectual property, is considered to be a big deal, right? It's not that.
Mhm.
So this is, I think, is a good idea to have obfuscation there, for example, or when you have sensitive data, when you retrieve information, that you have scenarios to when you need to I mean, I don't want to say the word encryption, but helping to give that layer of potential handling information sensitivity, for example. Or, oh, you know what, for example, how about when you have automatic attacks, when you did try to go find an if statement or a loop, you obfuscate that thing. When you have automated attacks, that can prevent a little bit obfuscation. I like
Mhm.
the fact that you're squaring this in terms of the open design, because I agree, obfuscation is a horrible way, it's a horrible practice to incorporate. But it's a great practice to have open design. For example, you talk about transparency, clear documentation, public peer review. But suppose if we use adversarial thinking, because this is what we're doing, adversarial thinking,
Mhm.
I will try to do the opposite of transparent, privacy. I will do the opposite of clear documentation, obfuscation. I will do the opposite of peer review, just a couple of isolation. So thinking
Mhm.
adversarially, which I think the opposite, I always want to think about obfuscate code for those reasons. And again, I think you answered my question. I just wanted to expand why obfuscation may be a good practice in terms of when you design some code.
Yeah, yeah. I'm glad that you brought this question up. You gave me some thought to go back. So always welcome. So in this slide, I want to design a login system, but this time we're focusing more on security of it. You know, so these are the requirements. It's quite common. We only have to authorize people who are allowed in the system. We are supposed to restrict the privileges of those user to do a particular task. So a particular user with doctor privileges can only do doctor related activities. A user with nurse privileges can only do nurse related activities. So again, and then login system is crucial to log information to reconstruct any unauthorized logins, right? So these are the requirements. Now can we take the learnings from our basic principles and design the system? Um, so what I'm looking at this is how can we use our basic principles and improve to build this system. So please feel free to take your notebook or write down what are the principles that could be used here. Why are we using this particular principle? How is it adding more value to the system? So that's a small task. If you guys can take 5 to 7 minutes and think about how we can use our principles to build a secure login system, that would be amazing. Is the assignment like is a small assignment? Is it clear for everyone, or is there any questions, assumptions?
Is there any questions from those folks who are here in the in the in the talk?
No, so you just want us to write down, like on our notebooks.
Or just probably shout out the first, like the basic principles that is used to build this login system. You can just shout out and talk a little bit about how we're using the first principles. So the goal is, using these principles, can we build a more secure login system? So that's the activity. If you guys can pitch in your ideas, discuss about how we're using this principle, that would be amazing. Can anybody tell us how we can use the principle of least privilege in this case? What exactly does that mean? How we be using that first? How we be using the principle of least privilege in login system? Probably with a scenario. Anyone?
We can give it a try. Yeah, give it a try, someone.
Yeah. I'm not looking into anything technical. You can probably just throw in some words and put things together. So
I can give it a try. For example, only allow authorized user into a system, right? Restrict user privilege to allow to the user login information to reconstruct and authorize login. Can you please show us the principles again so we can try to connect things?
Yeah.
And again, you spoke about several things, right? So I think I read, so okay, let me do the, since we talk about the principle of open design, right? So we can have a separation of duties where you can have the user authentication. Yeah, and well, the interface into asking the user for credentials, but then you can also have a different piece of code or different aspect when they can validate, but they don't have to consider that. They don't have to see it. For example, if you're using encryption is one thing, using hashing is another thing, is nobody's business. So we need to keep that separation of both things. So people understand that there's something secret, but we don't have to tell them how we achieving that. So it will be part of the open design. No?
That's good.
What do you think? What would be an ideal case?
So the open design, the way the authentication works has to be open, or we should use a standard authentication flow that is open. We're making sure we don't store username and passwords in the plain text, or probably in the product description, we tell the user how exactly we are handling the data. We are salting it, hashing it, and storing in a database, passwords or not. So we're not keeping um, anything out of users' knowledge, but the way we are doing it is using secure practices. So in your response, you mentioned about hashing, but I quite didn't buy it because we're not saying in this login system, we're not saying we're not keeping anything away from the user. You know what I mean? So principle of open design necessarily not necessarily means you should hide something, but yeah, as I think from your response, it really doesn't concern principle of open design. Does that make sense?
Yeah, absolutely. Can you give us a little bit more in the fail-safe default in this case that you propose?
Yeah. I think I spoke about this in my fail-safe defaults slide. So in case of login, there might be situations where only username is wrong or only a password is wrong, right? So giving the user, maybe you might have seen this in multiple other websites where it says password is wrong or username doesn't exist. So
Yeah.
failing safe here simply means do not again fall back to the secure default. So probably just print a generic message saying password or username is incorrect, or instead of exactly saying what is wrong. Just so that's one of the fail-safe defaults that could be utilized in the login system. Does that make sense?
Yeah, I think so. Anybody else have a question or a comment?
I think like one way we can implement the principle of least privilege in the password system is just like not giving a person like full access to like the website. So you're just like, well, like what the principle of least privilege is just like not giving like the person like just trying to give the person like the least amount of access they can have. Well, that's like the basic.
That's a good one. So we are totally believing on principle of least privilege here. Yeah, that's absolutely right. Um, Again, we can use separation of privilege here as well, right? During login system. Anybody want to give that a go? How we can use principle of separation of privilege when we are trying to build a login system? Okay, so again, every educational account probably or any critical information, critical accounts needs multi-factor authentication, right? So if we can implement multiple factors, while logging in as well. So we are strictly not, if a particular user has a password, that alone doesn't mean he's the owner of the user. But instead, if he has something, if he knows something and have something, which is basically what multi-factor authentication is, then we might go ahead and say, yeah, you have the password as well as another thing that only you can possess. So you are eligible to access the login system. So principle of separation of privilege is very directly utilized in login systems, right? Again, yeah, this goes without saying. Principle of complete mediation again is crucially important for login systems because there are certain scenarios where login system doesn't end with just logging in, right? Mm, Login system also has a lot to do with authorization, what kind of privileges the users get. So we should ensure every access to a restricted resource, every interaction with the subject and object is mediated. So I think principle of complete mediation is huge in designing the login system, right? Yeah. Also, I think setting up CAPTCHA. Anybody wants to see how setting up CAPTCHA improves security of this login system? Anybody wants to bring things together, put things together? How the or better question is, what exactly is CAPTCHA trying to achieve, or what principle is it trying to address?
Well, it's just making sure that like no bots can like access or like can make multiple accounts in the website, for example. It's a simple term.
Yeah. I think again, it is adding more on fail-safe defaults. It is adding more on separation of privilege. So yeah, I think now you can see how most of the principles come together to build a bigger system, right? Um, so let's get into some interesting stuff here. Are you guys? Can you guys give me some thumbs up, or if you learned something so far, or did I confuse you guys a little more, or yeah, because we're now diving into some hands-on exercises. So keep in mind all the theoretical stuff that I mentioned earlier uh, when doing this. So this goal of this exercise is to think in terms of principles, first principles. So this you can download this, or you can just visit this link in this slide and go over to that link and start reading the source code, I would say, and see if you can find some weaknesses, or point out certain things, or if certain things are not right, and see how our principles comes to the rescue. So this is a quick exercise, I would say, probably 5 to 10 minutes. Mostly you will be reading a lot of code and seeing if we can spot if something is not right, if something is not secure enough, or if something is not robust enough. So you guys can just visit that link and start reading the code, I would say. So a couple of strategies you can use here is following user input is one great thing, because when you're reading code, then it's easier for you to follow the user input and then see how because it's easy for you to figure out the flow of the program, right? User inputs A, and then this function is called, this function is called. So you know how the functions change. So one methodology is you can just blindly follow the user input. You can start reading the source code randomly, or you can check one functionality at a time, right? You can just look at login functionality if you can see any potential vulnerability there, or you can just look at password reset functionality, see if you can find something there. So this exercise is basically giving you an opportunity to probably look at some code, random code, and helping you think to connect the dots of if you can connect vulnerabilities with the principle, and then point out this is vulnerable because it is not following this particular principle, and this can be improved by so and so. That's the whole objective of this exercise. So I'll give you guys some time to read some code. Anybody's having any trouble with this, or I can
tell you, sorry for interrupt.
Yeah.
The majority of the students, I just saw them. It's a great code, the PHP and everything. We can give it a try. Were you
Mhm.
planning to trace? Were you planning to trace some of those examples?
Yeah, I can give you some headers, like the main points to look at.
Okay, so let's why don't we just give like 3 minutes so you guys can take a look at those files. I'm reading it right now as we speak. There's a couple of things. Don't feel intimidated, guys. I think when you read them, you think is like, oh, what is all this? But I think Schwab already gave us an explanation about what we expect. especially with the MySQL. If you're not familiar with MySQL, don't worry. That's how you connect to databases, but it's okay. Okay. So let's have 3 minutes to take a look at those. And I know some of those, Java guys, they look like Java is called JavaScript. So don't worry too much. It's very similar as Java, but at the same time, it's principles.
Or I can instead do one thing that kind of brings everybody to pace. I can go to the next program and give you,
that would be great. Yeah.
then probably we can circle back to that, if that is okay. Okay, so this is from a program, this is from a project called Apache Flink, and it's an open source stream processing framework. And in this particular slide, we have a particular class called job manager custom log handler. So this might, again, don't worry about it if you don't understand any of it, but I'm trying to demonstrate how I look at things. So if you don't understand anything, it's fine. So just by looking at it, we can spot a couple of things, right? It's extending a class, and then there is a constructor in the line 42, which takes a lot of parameters and then just calls super on those parameters. And there's one exception there. If you see line number 49, if you look at line number 49, line number 49, then logger is being set to the constructor, right? Okay, so what's happening in line number 52 is that we are trying to override get file function. And what's happening here is there is a string called file name, which is being created, and from that file name, we're creating a new file with that file name. Okay, so this is the overall overview of what's happening. Okay, now let's think what might happen, what might be a vulnerability, or what could be improved here. We have no idea about, no way we can, there's something insecure about the constructor, right? It's just setting few things, and yeah, it's just a constructor, so it's doing its job. Main potential vulnerability could be at the function get file here, right? Okay, let's now think about what happens if the log value is, as you can see at the right side of the slide, what happens if the logger value is /var/logs. Okay, and let's assume what happens if the file name is //etc/p password. Okay, let's now work with this. Okay, okay, I think anybody's aware about directory traversal attack. Okay, or I can speed things up. Directory traversal vulnerability is basically when an attacker can manipulate the file name in such a way that it allows the attacker to escape the intended directory and access the files outside of it. So when we normally upload files, it has a file name and everything. But what if the file name has .. attached to it? So if you're proficient with using terminal, then I'm sure you know .. means you're going one step before your current directory, right? So in terms of file name here, what's happening is the new file created is a concatenation of logger and file name. So when you concatenate var logs and the file name, it essentially becomes etc/password, right? I hope everyone's with me till now. So when essentially you're creating the file, which is the file of which is a sensitive file which you don't have access to. So my approach was looking at the file, looking at the code, narrowing down my focus to a particular function, then understanding how what might happen if I pass a malicious uh, input to the function and see how it reacts. So that's my understanding of the program, and yeah, I think this is an example of a very good example of how directory traversal vulnerability could be exploited. It's quite simple, right? To fix this, then you should just sanitize the name and ensure it cannot have any weird symbols like dot dot slash or anything. So if you just sanitize the file name, and then normalize the path, then you can easily prevent this type of attacks. So if you look at the next, oh, okay, if you look at the implementation of this, then you can see here how they have handled this vulnerability. So they have now created a new file after calling getName method here. So getName method here in the line number 61 is basically normalizing the path. So whatever, if you have dot dot slash something, and you pass that to a getName function, then it'll strip all the dot slash or any of those malicious things and gives you a absolute path. So then if you see line number 61, you are also creating a new file with it. So you know the file name is not malicious here. So once the file name is not malicious, you can work with logdir, because logdir is not used in any of the override functions. So yeah, so again, this is how I look at things. This is one approach that I take. So now I think we are well equipped to go back to this exercise and now read the code. So first thing I would say is do not get intimidated by the code, because a couple of reasons why you could be intimidated is you're seeing it for the first time, because most of the time if you're working in a corporate, you're looking at new code all day. So do not get intimidated. Try to reduce the code into an abstract functionality. Then look at how that functionality could be exploited, and then how it could be improved. So that's my methodology, or that's what I'm comfortable with, looking at functionality at a time and seeing what are the ways that you could exploit it. So I think it's okay. I can probably, yeah, I think I can give this as a take home assignment or activity for you guys to uh, build on the first principles and reading some code, putting these things together. So I think this could be your exercise for the future. I think anybody is not clear about what's happening here, please feel free to shoot me a question.
I have a question about the open design.
Yeah.
So the reason we do open design is because, like, for example, if like our system's like a closed design, for example, and it gets leaked somehow, like we're not like preparing for like we're not really preparing, how do I say, like we're not really preparing like to write code to like prevent that happening. Do you get me? So like the reason I guess we would do open design is so like we can be prepared, like we can we can like write code, like just like how do I say it? So the reason we do open design is so like we're not just like like sorry.
Yeah, take your time.
Yeah. So okay. The reason we do open design is so like we can already have like the securities and like the code like already implemented, and like not just like wait until like our design gets leaked, for example, and like now we have to implement that because like we thought like our design was closed or like secure, for example.
I'm kind of getting your point. The principle of open design says that if you keep your design secure, or if you don't, if you're depending on your design of your program secure, if you keep your program's design closed, that doesn't mean the program is secure, right?
Mhm.
Just because you don't make it public doesn't mean some hacker cannot figure out what's happening, right? Instead, the better way to do it is tell everybody what's the design and then probably ask them to break it, because hiding design is not equal to security. Or again, so we all know there are a lot of uh, cryptographic algorithms like SHA-256 and so many of them. Why do we know you cannot break some of them? Are because we know most of the algorithms, right? Why? So what's stopping us from breaking it is not the way, not the way. It's everything to do with how long it takes to break a particular thing, right? So if it's say SHA-256 is, everybody knows the source code of SHA-256, but how are we believing on it to be secure is it takes humanly insane amount of time to just track one such password, right? So even though it is open, we can assume it is secure because it takes humongous amount of human hours to crack the code. So again, we're not saying if keeping your design closed means secure. Instead, we're saying keep your design open, but make sure the way you implement it and design it and implement it such that it's almost impossible to break it. Does that answer your question? I think I kind of went in.
It answers my question. So just like keep it open and just like make sure the code is like secure
I mean,
enough.
yeah,
So,
I
and
think
so
TLS and SSLs are the great example for that. So the protocols are open for everybody, right? Probably OpenSSL might have some flaws in it because it's again it's a implementation of the particular protocol. So even yeah, that's the simplest example that I can think of right now. TLS, SSL, and OpenSSL. So yeah,
thank you.
no problem. Yeah. So yeah, this is one simple. I think I spoke about this, how sanitizing the input helps, how safe file creation helps. So how we're trying to tackle this issue using a simple fix in the next line. Yeah, I hope you guys got a broader understanding of what secure coding is. Again, I'm not sure if did a great job, but I want you guys to take away that secure coding is mostly about proactively figuring out what might go wrong, what intentionally or unintentionally, and fixing them, following 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 the principles of secure programming. So that you don't accidentally see some surprises, bring loss to the company, or anything for that matter, any bad consequences. So yeah, I think this is a further reading for for everyone. OWASP is a must and should for all security folks to understand what secure coding is. This is a developer um, guidelines to write secure code, and Secure Coding Dojo is another project of OWASP, which is like a small hands-on tutorials to learn about input validation, input sanitization, a couple of things like that. Yeah, this will be our further reading, and this will be your exercise. Um, it's totally okay if you don't get any of the code, but it's important that you can start thinking in terms of robustness and security of your program from now on, and constantly make an effort to write secure code. And yeah, it's basically future proofing your program, right? So yeah, that's it from my end. If anybody have questions, I'm happy to take it up.
Thank you so much for your presentation. This is super helpful, especially because you cover the main points for secured coding and adversarial and defensive coding. So I want to thank you for your hard work. Thank you everybody for attending. I know it's a little bit late, but at the same time, this is super beneficial for many of us who are in this area. Thank you.
Thank you so much, Professor, for giving me this opportunity. I'm not sure how I did, but I hope some value out of this. And yeah, thank you so much.
Oh, you did that absolutely outstanding. Thank you so much. And thank you, everybody. I hope everybody's doing well. Happy coding.